Okay, this first presentation is in response to exam 1B, question number 3, primary versus secondary responses of the immune system. I'll be comparing those two responses, but first, for any of that to make sense, I'd like to back up and consider the innate immune system and the adaptive immune system. So when we talk about the immune system, what we're really discussing are two concurrent systems that are different but not separate. They operate concurrently, simultaneously, and these two systems are the innate immune system and the adaptive immune system. So the innate immune system refers to these non-specific, these generalized defense mechanisms. They come into play immediately or within a few hours of an antigen's appearance in the body. These mechanisms include physical barriers, skin, mucus, chemicals in the blood, immune system cells, and it's activated by the chemical properties of the antigen. So this is sort of the inborn, that's why it's called innate. It's inborn or instinctive. It's genetically coded for. We evolved alongside some pretty common pathogens, and the innate system is this sort of general catch-all that tries to stop most of those common invaders. So when you need something a little more specific, that's when you call in the adaptive immune system. So the adaptive immune system refers to an antigen-specific immune response. This adaptive immune response is a little more complex than the innate one. It's a little more evolutionarily sophisticated. The antigen is processed and recognized, and once it's been recognized, the adaptive immune system will start clonally producing an army of immune cells that are specifically designed, custom made for that antigen. And so during the this cloning process, where the cells reproduce themselves with antibodies custom tailored to that antigen, many of those clones will lag behind, and they become what are known as memory cells. And this is sort of where the difference between the primary and the secondary response comes in. So when B cells and T cells, the lymphocytes, are first activated by the pathogen, some of those will develop into memory cells. Now, for the rest of that animal's lifetime, or at least those cells' lifetime, these memory cells will remember. I hate using personification-like terms when I'm talking about things as unconscious and unperson-like as cells, but for clarity's sake, I'm forced to use such terms. So throughout the rest of that cell's life, it will be able to remember each specific pathogen it has encountered, and it's therefore able to mount a strong response if the pathogen is later detected. So the primary immune response occurs when an antigen comes into contact with the immune system for the first time, thus the primary response. It's during this initial contact that the immune system learns to recognize the antigen and how to make the antibody against it, and produces those memory lymphocytes. However, during the secondary immune response, which occurs the next time and the next time and the next time the system is exposed to that same antigen from before, this is when the memory that was formed during that primary response is recalled, and the immune system can now make antibodies immediately instead of waiting to communicate that information. So just some key differences here between the two responses. The primary response occurs as a result of primary contact, that is to say first contact with an antigen. The secondary immune response occurs as a result of subsequent exposures to that same antigen. In the primary immune response, the cells that are called on duty are the naive B cells and T cells, that is to say the lymphocytes that have not learned about this particular antigen yet. But in the secondary immune response, what is called upon are the memory cells, which are actually lymphocytes, but ones that have the adapted memory of that initial antigen encounter. So the primary response has a lag phase that is much longer, usually about a week, could be several months in duration, whereas the secondary response, much more quick acting, peaks out in just a few days. Its lag phase is much shorter, probably about 1 to 4 days, thanks to those memory cells quickly enacting their effects. The level of antibodies in the body peaks out in about 7 to 10 days during the primary response. But with the secondary response, it's about half that time, about 3 to 5 days before the antibodies, the level, the concentration of antibodies in the blood peaks out. For the primary response, it takes a bit longer time to establish full-fledged immunity to the pathogen, whereas in the secondary response, that time is much, much shorter. In the primary response, the first antibody produced is mainly immunoglobulin M, although a small amount of immunoglobulin G is also produced. Contrast that with the secondary response, where it's mainly immunoglobulin G being produced, although sometimes small amounts of immunoglobulin M are produced. Other immunoglobulins such as A and E are sometimes produced. In the primary response, the amount of antibody produced depends on the nature of the antigen. It's usually a low amount. However, in the secondary response, it goes all out and produces 100 to 1,000 times more antibodies. Now, in the primary response, the antibody level will drop off rapidly, but with the secondary response, that level will remain high for a longer period. Now, in the primary response, the affinity of the antibody for its antigen is much lower, but there is a much greater affinity for that antigen by the antibodies in the secondary response. In the primary response, the activity is mainly found in the lymph nodes and in the spleen, but in the secondary response, the activity can be found in the marrow, the bone marrow first, mainly in the bone marrow, and then the spleen and lymph nodes follow suit. Finally, we have the relationship to the thymus. Both thymus-dependent and thymus-independent antigens give rise to the primary immune response. However, the secondary immune response is only mediated by thymus-dependent antigens. And so those are ultimately the differences between the primary and secondary immune response. The innate immune system changes little between the primary and the secondary immune response, but the adaptive immune system exhibits a great number of physiological changes between the primary and secondary a mean response.